This slide introduces the concept of angular frequency and a complex number. We have a phasor z in green with one end centered at the origin and it is rotating in this complex plane. Here the horizontal axis is the real axis and the vertical axis is the imaginary axis. The phasor is rotating at some speed around the origin. We measure this speed of rotation by a scalar that tells us the number of rotations per unit time. The name for this scalar is angular frequency, and the symbol used to denote angular frequency is commonly the capital symbol omega. By convention, we measure the rotation with respect to the positive real axis, and hence the positive omega results in a phasor rotating counterclockwise, whereas a negative omega results in a phasor rotating clockwise. Let us have a concrete example. That is, if theta varies with time, if it takes 1 second to rotate the phasor by 1 revolution counterclockwise, and since 1 revolution is 2 pi radians, then the angular frequency is plus 2 pi radians per second. By convention, we measure theta with respect to the positive real axis, and hence a counterclockwise rotation results in an angular frequency of plus 2 pi radians per second, while a clockwise rotation of 1 revolution per second will result in an angular frequency of minus 2 pi radians per second. And if we have a faster rotating phasor counterclockwise, example, if it takes only 0.5 seconds to rotate the phasor by 1 revolution, that is 2 times faster than the previous phasor, then the angular frequency for this particular phasor is 2 pi into 2, which is plus 4 pi radians per second. Since the phasor z is in the complex plane, it can be decomposed into its real and its imaginary components. Specifically, we can write z is real part of z plus imaginary part of z, which can also be described as r cos theta plus j sin theta. Here r is the length, or another term, the modulus of phasor z, and theta is the angle between z and the positive real axis in radians. By Euler's formula, we know that e raised to j theta is cos theta plus j sin theta. Therefore, we can also write z as r into e raised to j theta. In this particular case, value of r is 1, and we have plotted the z on a unity circle. If we have a faster rotating phasor counterclockwise, example, if it takes only 0.25 seconds for the phasor to rotate by 1 revolution, that is 4 times faster than the first phasor we looked at, then the angular frequency for this phasor is 2 pi into 4, which will be 8 pi radians per second. And the phasor z can now be represented as z is r e raised to j 8 pi t.